Dear colleagues, I would like to welcome you to our today's webinar entitled Research Data Management in the Life Sciences, and the subtitle From Writing DMPs to Rdm Practices and Rdm Support leads us to the real content, namely data management plans, real lab practice, and research data management support. As can be seen from the logos at the first slide, this webinar is a joint activity of several organizations, namely MedUni Graz, Biotech Med Graz, and Fair Data Austria. So for all of you who are not familiar with either Biotech Med Graz or Fair Data Austria, we'll get a short introduction into both within the next few minutes. My name is Peter Schaffer. I am from MedUni Graz, and my today's job is to guide us through this webinar. Now, as can be seen from this slide, this webinar is part of a larger series, and the series is called Research Data Management in Austria, which aims at both researchers and research support staff and serves to promote networking and exchange on the topic of research data management. I would like to point to the fact that this webinar is going to be recorded and that both slides and recording will be available on the Fair Data Austria project website within a few days. Now, at this point, a few technicalities. Although we are in a pandemic since more than 1 year and we are well accustomed to web meetings, we would like to point to the fact that all of you should mute your microphones to avoid any background noise. You will find the mute button on the lower left side of your WebEx screen. And again, we would like to point to the fact that this webinar is going to be recorded. For any questions throughout this webinar, please use the chat function. You will find the respective button at the lower right side of your screen. And we will try to answer, depending on our time resources, answering directly in the video and audio, but otherwise we'll try to provide an answer directly in the chat. And if it's possible, when you raise a question, please indicate the person to whom you are addressing this question. This makes it easier for us to give proper answers to your questions. Now to our agenda. So the webinar will be opened by Vice Rector Caroline Schober from MedUni Graz. She will give us both an opening statement as well as an introduction into Biotech Med Graz. We will then continue with a general introduction into research data management, as well as an introduction into the Fair Data Austria project given by Ilire Hasani Mavriki from TU Graz. From this introduction, we'll move on to Katharina Rieck from FWF, and she will give us an introduction into the FWF data management plan. Planning will lead us to acting, and then Gustav Obadwarfa from TU Graz will explain the necessity for RDM in his field of expertise, namely computational protein design. And last but not least, all three Biotech Med Graz universities will show us their central RDM support. And these presentations will be given by Sarah Strujek for TU Graz, Christian Kaya for Uni Graz, and Therese Macher for MedUni Graz. But now we will move on to Vice Rector Schober, and I would like to welcome her to our webinar. Caroline Schober is Vice Rector for Research and International Affairs at Medical University of Graz, but she's also chair of the Executive Committee of Biotech Med Graz and also member of the Expert Group on Open Science 2.0 of the European University Association. So Caroline, the stage is yours.
Thank you very much. I'm very honored to be able to welcome you here for this really interesting seminar. I wished I could listen to it myself. First, I'll use to introduce you to Biotech Med Graz, because especially those of you who are not from the Graz area most likely don't know this initiative. It is a research alliance which was founded in 2013 by the three scientific universities in Graz, which is the main university, the University of Graz, the Graz University of Technology and the Medical University of Graz. And it focuses on merging the research activities that are in those interfaces that connect basic biomedical science, so basic research, technological developments, and the medical applications, both clinical and outside of the clinic, and how to connect those. So it's mostly focused on basic research, but with a strong translational perspective. And there are three research areas we're focusing on. It's molecular biomedicine, which is the biggest part, neurosciences, pharmaceutical and medical technology and biotechnology, and quantitative biomedicine and modeling, which is growing in its importance, of course, and also in the number of people that are working in this digital fields. And they are directors of this consortium, which are currently Rudolf Zechner from the Uni Graz and Robert Krause from the Medical University. Next slide, please. What are we doing there? And this is just a glimpse and a selection of activities. So they are flagship projects, which are larger consortium projects where we really fund those as as a very large pilot project, so to speak, for other funded projects. There are SFBs and doc funds coming out of those. We promote young scientists with young researcher groups, and we have currently 3 female PIs in their groups that should bring them to independence, because very often it's hard to get this step from being a really good postdoc to becoming an independent group leader. There are lab rotations very early on for PhD students to be, so that it's not the typical thing to do your thesis, your PhD thesis, where you did your master's thesis, but to look around, look into other fields. So there's an open call. Maybe in your vicinity there are people interested in this, so you can very likely circulate this. We are currently trying to set up a new institute together with the Austrian Academy of the Sciences, the ÖAW, which is called CORI, which were 2 researchers in the field of molecular biology and metabolism. And we're trying there to make the connection between molecular research and computational research in the metabolism area. So you see this is all very data-driven approaches. You generate the data, you use it, and you don't have just the data to show what you did, but also have an extra use or a special use for the data. And we are running common infrastructure and trying to use core facilities at the various institutions, but also, and this is kind of my step onto data management, is to go more into how to manage data and to create infrastructure that can be used by a lot of people. And today you will also hear about a project I'm sure that was set up within Biotech Med, which focuses on the exchange of those data and also the possibility to use computational pipelines from all different universities, no matter where you sit, and have a common grounds for this. And I remember back in the lab a long time ago, those data management was always an issue. And when I was still in the lab, it was a paper book that you would write your data in, and then your colleagues would finish their thesis or go away for whatever reason. And then you had to find out what they did and go back to their data, which was more or less impossible, or it was a treasure hunt. So we tried to do it in an electronic form, which was really hard because then, of course, it was not tamper-proof. You could fiddle around with your data later on and you wouldn't notice. It was also very, very hard to find, especially in a world where everybody has their own server or their own space on a server, and floppy disks maybe, or ZDs where you would, or DVDs where you would put your data on because your hard drive was full. And there's both accessibility and security. And I'm not talking about FAIR principles here, but just getting your hands on the data physically was much of an issue. And I remember like 15 years ago, we had the first approach to saying we want, or pretty much in more than 10 years ago, to have an electronic lab book. And as far as I know, none of the 3 universities, at least in Graz, and I don't know of any university in Austria, has a common infrastructure for an eLab book and a structured way how to go about this. And it's a technical issue. You don't want to be locked in. You don't want to spend tons and tons of time and money on a system that you might not be able to use in a couple of years from now. But on the other hand, everybody's trying to do things on a more of a lay people's approach. And so I think it's super important that we have initiatives like Fair Data Austria and other initiatives, both which are funded, but also those that are just bottom up without additional funding, which of course is very hard to get your move on and to be fast enough. That is not just talking about data management, because it's so easy to talk about policies. And we do this a lot at the European University Association. We write policy papers, but what it really needs is to get it down to how to apply it, because the average researcher, the average research service support person needs to know what to do. And this is an infrastructure issue, it is a software issue, it's a human resource issue, both quantitative and qualitative. And it really needs to start with the very young students. It's definitely too late if it starts very much advanced in this process. And we also need to be certain that and just recognize it, that it will cost us some money, and that a substantial amount of money that we need for our research will have to go into research management. And of course, the issue is to limit the amount of resources that go into it, but still get a lot of positive out of it, and a lot of functionality out of it. And so I think those seminars like you have now are very, very important step into this direction, also to broaden the awareness of that this is an issue, because I have the feeling that because it's tricky, a lot of people like to push it away and work with on a very low level if it comes to research management. And so that funders are asking us that we have to have research data management plans definitely is something that accelerates this process. But it's one thing to write things down and to think about it, and it's another thing to live it every day and to really make things accessible, at least for the group, and if possible for those beyond that. And there are many issues like quality assessment, which is super important, because even in the old days, you didn't want to use the data of most of your colleagues, and at least you knew them, so you knew whom to trust and who not to trust. And now you're talking about more or less anonymous people somewhere in the world, and you want to use their data. I think it needs some safeguarding in what to use and what to do. So you're not just producing artifacts because things are there. And with that, I want not to use too much of your time, because you have a very tight-fitting agenda, and you're all there not to hear me, but to hear the interesting speakers. And I hope you have a great seminar. Thank you very much.
Caroline, thank you very much for opening statement, your personal point of view, but also the broader perspective, and also for giving an introduction into Biotech Graz, since Biotech Graz might not be very well known east of Wechsel, north of Hochschwab, and west of Vorarlberg. Thank you very much. And I have to point out that Vice Rector, proceed with our webinar. It's your turn, please.
Thanks a lot. Thank you, Peter. Thank you for very nice introduction and very kind words. I will try to share my slides now. It will take a while, and I hope that everyone can see them also in the.
We see them, but not in the presentation mode. Yeah, now it's presentation mode. Thanks.
Okay.
It works.
Thank you. And I will give a general overview on research data management, and I will introduce also the Fair Data Austria project. I will also pick up on a very nice introduction that we got from the Vice Rector. So many issues that she already mentioned are still present, but of course a lot of improvement and a lot of progress has been done in the latest years. So the new technologies for accessing, processing, analyzing, but also sharing data enable us to collaborate with others, and also enable us to rapidly advance our research. In other words, these new technologies enable the data-driven scientific research. Data-driven science accelerates also the flow of knowledge between different disciplines, and this gives us the opportunity to get very important insights, as insight is also contributions that are of a high social impact. Only in the recent pandemic, we have seen how important the transparency of our research became. It means that the open science principles became really important, and also we saw an increased need to demonstrate impact and visibility in research. Saying that, can we agree that research data are becoming first-class citizens of our research output? Maybe before addressing this question, just shortly, what do we mean by research data? As researchers, but also as support staff, we deal with different kinds of research data. And for this seminar, I would like to stick to the definition that research data is any information that has been collected, observed, generated, or created to validate original research findings. And going back to the question that are research data really first-class citizen of our research output, I would agree if research data are of a high quality, are well described, are well structured, are properly stored, and if possible, are made available to others. So exactly what also Vice Rector said, that the trusting the data of others, it's really an issue. And we see an increased demand on high quality for research data coming from different stakeholders, from funders, from publishers, from ethical committees, and also from universities. How do we address this demand and how do we fulfill these needs? Indeed, research data management is one of the solutions. Here I just provided some definitions, and I think we can agree with all of them. Research data management ensures that the power behind the research data that are locked behind the publications is unlocked. Research data management actually begins with the thinking through all phases of the research life cycle. And saying that, it also complements research from the initial planning stage all the way to archiving, reusing, or deleting research data. In other words, research data management should prevent us to lose our research, our valuable research in a lost laptop. Of course, there are a lot of challenges in addressing research data management. We know that Google and other publishers, they also manage our publications. So research institutions and researchers, they have to try to achieve and retain sovereignty over research data. We experience, and we know that data-driven science is here to stay. So research institutions must support researchers to find new ways how to benefit from data-driven research. We already heard that funders are demanding high-quality data and the proper research data management. So research institutions have to train researchers, and especially those in early career stages, to professionally handle research data management. One of the foundations of research data management are the so-called FAIR principles. So what does it mean to apply the FAIR principles on your research data? It means that you make your data findable. In other words, others can discover your data. It also means that you make your data accessible, so your data is made available to others. It also means that you make your data interoperable, or in other words, your data can be integrated with other data or can be used by machines. It also means that your data is reusable, so it can be used for new research. Applying the FAIR principles to your research output, it doesn't necessarily mean that, for example, your research data is openly available to others. Open data means that your data is available anytime to anyone for any purpose. On the other hand, FAIR principles are just best practices that show you how can you make your research data available to others and at the same time comply to ethical, legal, and also contractual regulations. So if there are restrictions based on these regulations, then and you cannot make your data available, you can at least make sure that you describe your data properly so that anyone who is interested to have access can require access for a particular purpose. Addressing all these challenges that I already mentioned is one of the goals of our project Fair Data Austria. Fair Data Austria is a 3-year project funded by the Ministry of Education, Science and Research. It is led by TU Graz with Technical University of Vienna, University of Innsbruck, MedUni Graz, and Academy of Fine Arts in the core team, and we also have 23 associated partners. Our mission is to work together to create the conditions for the future of data-driven science. How do we achieve this? With a very ambitious team who is creating researcher-led fair services, who is also developing social and technical solutions in parallel, and who tries to fill the gap between researchers and support staff. As a team, we want to make sure that we align our research data management activities on a national and also on an international level. So we are part of different initiatives and we contribute to different working groups, for example, in Research Data Alliance, in GoFair, in European Open Science Cloud. We are also members of the Carpentries, CESAR. We are part of Cyber's US as a collaboration in a project that will be introduced later on. And we work together in a collaborative project with CERN to implement repositories for research data output. What do we actually want to achieve within the project? In collaboration with our project partners, we are working on so-called hard infrastructure elements. So we want to implement a management tool for the whole research data lifecycle with a keyword machine actionable data management plans. We want to also implement repositories for long-term archiving of research results, research data, code, and databases. And we also work on a so-called soft infrastructure elements. We are developing Rdm training and support services. We are working on a toolkit for models, profiles, and training offers for data stewards. And we are also establishing the FAIR Office Austria and a network of FAIR reference points. Our main principles are: we want to encourage researchers to make their data as open as possible and disclosed as needed. We implement our tools that can be as general as possible and as discipline specific as needed. And we want to make sure that our services reduce the manual work through the automatized RDM workflows. In regard to general and discipline-specific tools, services, and also requirements, our recent work has shown that the requirements and the needs coming also from researchers, they fall into two classes. Discipline-specific requirements, which are mainly based on different research goals, on different methodologies and practices, and maybe also on departmental backgrounds. For example, there are different metadata standards, or these metadata standards are missing. There are different intellectual property rights that researchers have to comply with. There are data privacy issues, and also there is a different kind of culture how to deal with archiving research data. So these requirements should be addressed at the discipline or at the faculty level. And on the other hand, there are some general or discipline environment requirements such as findability, organization of the research data, the requirements coming from the funding agencies, and these can fall into the scope of general Rdm policies, tools, and services. How can we deal or how can we address these two levels of requirements? One possibility is to address these through the Rdm policies. And as we are now speaking on the terms of also GRAS universities, so all GRAS universities have an Rdm policy. And here I just want to point out an example from our policies, so from Graz University of Technology, where we have also faculty-specific Rdm implementation strategies. So we have a two-level of Rdm policy, the framework policy, which defines a higher level roles and responsibilities, which means on the level of IT department, library, F&T house, but we have also defined faculties there, and then we have faculty-specific implementation strategies of this framework Rdm policy, where we define roles, responsibilities, and rights on a lower level, speaking PhD supervisor, PI, PhD student, or individual researchers. And then we handle also rights, specific rights for each faculty. How do we make sure that these two kinds of policies are interoperable? By defining the faculty role in the framework policy with minimal general requirements, we make sure that these faculty-specific implementations are interoperable. And we are very proud that now we have the very first faculty-specific Rdm implementation for the Faculty of Mechanical Engineering and Economic Sciences, and you can check the policy also in the link showed in this slide. Going back to the tools, so these two kinds of general and discipline-specific requirements, of course, can be handled with different tools and services. In my talk, I will concentrate on two kinds of tools that we are implementing within the Fair Data Austria project, which handle more the general requirements and needs of researchers. And in the later talks, you will learn more about discipline-specific tools and services. So DMPs, of course, it's an important requirement coming from the funder. And the goal of the DMPs is to help identify what data are generated, how the data within the project is collected. And of course, it helps researchers to plan the publication of the data, for example, including also open access if needed. But we experience that writing a DMP is usually done, of course, manually, and these documents are static documents that are not kept up to date, and from researchers is considered as a burden or as an admin task, therefore has also a low priority. We want to address all these issues by implementing machine actionable data management plans that help at least semi-automatically manage some of the Rdm tasks that are in the scope of DMPs. So we want also to create some pre-filled DMP templates to avoid the black page syndrome for researchers. And we are working closely with FAF. And of course, the main goal of our team within Fair Data Austria project and FAF is to provide high quality DMPs. On the other hand, we are working on implementation of repositories for publications, research data, and also educational resources. So we are using Invenio Rdm as a software solution for this purpose. Our developers from TU Graz and TU Vienna work in the core team with the CERN, who is leading this collaborative project. And recently, at TU Graz and also at TU Vienna, this solution is available, and new features are added on a continuous basis. On the other hand, we are also working on Rdm training and support. So within the project, we have created a concept for cross-university training, and this concept has 3 levels. So we have a curated training collection, which can be used independently of time and location. So this is also very suitable for self-study. Then we have established a webinar series with a title Research Data Management in Austria. And of course, this seminar is part of this webinar series. And then on the third level, we also plan institutional training. So each university can, based on the needs, can offer trainings for their researchers. As already mentioned, we are working also on a concept for data stewardship on a national level. So together with all our partners, we want to define the roles of data stewards, tasks, skills, competencing, and also training programs. As an example, here I just want to show that at TU Graz, we have already 3 data stewards in 3 disciplines: life sciences, mechanical engineering, mathematics, physics, and geodesy, and they advise and train currently over 30 institutes. We have also a data champions program with 15 data champions that we identified at TU Graz. They are also advising and working with 7 pilot projects in terms of RDM. Of course, they play a special role in rolling out RDM tools, and they are very active in exchanging with scientific community. Fair Office Austria is also one of the activities within Fair Data Austria. So we have already a website. You can check the link in this slide, and I would like to invite you all to our lunch event, which already takes place tomorrow. So here you have also the link to the registration. So to find more about this, I would invite you to attend the event tomorrow. I want to end my talk with this citation. So we have seen there are a lot of challenges ahead, and research data will not become nor stay fair by magic. So we need skilled people, transparent processes, interoperable technologies, and collaboration to build, operate, and maintain research data infrastructures. Thanks a lot. And if we have time, I'm happy to answer your questions.
Ilira, many thanks for your clear presentation about general RDM and Fair Data Austria and also the local developments at TU Graz. You pointed to challenges, and I think challenges are really ahead of us, and we are right in the schedule, but I think we should take the time to make a few question and answers. I would like to point to the chat. Barbara posted a link to an event which will take place tomorrow. We still do not have questions in the chat. So if you have any questions on this topic, please.
Yes, that's me.
Okay.
Thank you.
We can do it via microphone.
Okay.
Your turn.
So that's Joachim Reidel from the Karl Franzens University. I have thank you very much for the talk, and it's really an open field thing and a lot of specific and specific stuff is coming over the researcher in the near future. And my question is, what kind of strategy are you pursuing in making sure that the journals requirement to publish and also to file applications for instance, FWF or EU, and they have requirements that you announce data storage systems and that they have accessibility to it, or if you publish in journals, in international journals which have their requirements. So how do you get sure that you always how to say, that you always fulfill the requirements there? Are you in contact with them, or are there international standards, or what is it?
Of course, some of the requirements, they are aligned internationally. For example, if you speak about requirements coming from funders, but also from publishers, Science Europe is the best address. So we are considering all the advices that come from Science Europe. For example, for the machine actionable data management plans, so we are implementing this template, this broader template that is published already recently by Science Europe. So there are alignments on international level, And as I showed you, our team is involved in these initiatives, and we are trying to be on track and to get all the information. And of course, then some of the requirements come from the researchers. So when they have to provide an answer regarding research data management, they contact us. So it's also a bit of a duty of each RDM team or any other offices at the university to spread this information to researchers. And the best solution would be to have an institutional repository. So we are working on rolling out now this Invenio RDM solution to many universities in Austria. So there the researchers would have the possibility to publish their data if this is a requirement from the funder or from the publisher, if it's possible to publish it openly. So they can also sign a DOI. And of course, the publisher or the funder can check that. But even if there are some restrictions, they can still make the data available, at least the metadata, and show the publisher that, okay, the data has been archived in an institutional repository. So if you need more information or if other collaborators need more information, they can contact them.
The presentation given by Katharina Rieck will give you a nice introduction into this topic. So Katharina, it's your turn, please.
Thank you very much. I'm now going to share my screen with you, and I hope that works. So you should see my screen now.
We see it, but
yeah,
not in the presentation mode yet. Now the presentation mode. Thanks.
Yeah, okay, perfect. So thank you very much for inviting me to talk about the funder's perspective on research data management at this workshop or at this seminar. I'm going to focus on so the Austrian Science Fund's research data management policy, but also on the data management plan. We do have a data management policy that requires a DMP since 2019. So for all projects that are approved by the FWF board, you have to hand in a data management plan. And at the same time, we do have a mandatory open access policy for research data. And I'm going to talk about those two policies now and go into more detail. When it comes to research data management, I mean, we've already heard a lot by Ilira and Mrs. Schober-Trümmler, but I think it's still worthwhile to also have a look at some data on research data management. So there have been some studies around research data management, and I wanted to show you this one, which is researchers and their data. That was a big survey that was conducted in Austria in 2015. And one of the questions that was asked and so researchers were asked, and one of the questions that was asked was, where do you usually store your data? And most answers were locally on my work computer or external hard drive or USB drive. These are the places where I store my data. And it's not surprising that also more than 1/3 of the researchers that answered those questions also said that they already have had experiences with data loss. I think it's easy to understand that if your data is only that you worked on for several years and it's only on the USB drive, then it's easy to just lose it, and so the data is gone. A second question that was asked, or among the many, was, do you normally document your research data? And there also you can see most people said, I do it individually and not consistently, or I do it individually and consistently. But it also points to what we've heard, a big topic that we've heard by Ilira already, is metadata and describing the data. So no standards are used when describing the data in most cases. What does that mean? What are the consequences by working that way? A lot of studies are just irreproducible. So there was this study on that looked at different studies that are out, and they found that most of the studies were not possible to reproduce because either the data was not available or the data was not documented well enough. And Nature actually asked specifically this question to around 1,600 researchers. Do you think there is such a thing as a reproducibility crisis? And most actually answered yes, there is such a crisis. 52% said yes, there's a significant crisis that we are facing, and 38% said yes, there's at least a slight crisis when it comes to reproducibility of research results. So why do we ask for a research data management plan then at FWF? I think it comes out quite clearly and was said already before. It's because we want to ensure that the data that is produced during projects that are funded by the FWF, that those projects produce fair data. Fair data does not mean, as we've heard before, and I'm going to talk about this later also a bit more detailed again, does not mean all your data needs to be open. It just means it needs to be findable, and that means that on the one hand, the data itself needs to be findable, but more importantly, the metadata needs to be findable. So the information about this data set exists somewhere out there is very important. Then accessibility, interoperability, and reusability. And this helps to avoid data loss. It saves time and resources because, and we've heard that also before, it just simply helps because you don't have to reproduce data over and over again, or data sets over and over again, because you can just reuse the data if it's data that already exists, if it's documented well. It, so to say, accelerates the research process, and by opening data up or by making it accessible, new insights through the consolidation of data can come out. And also there can be a creation of higher value data products such as databases by just simply merging existing data sets. And just to sum it up, why do we ask for research data management? It's simply good research practice. And you can find that also in several documents. I'm linking here to one that was published last year by the Austrian Hochschulkonferenz on research integrity. And good research data management is just one very important key element of good research practice. So not only in Austria, but internationally, research funders ask for a research data management plan. And even before the FWF did so. So you can see here, I listed only some of them: the NIH in the US, the Wellcome Trust in the UK, SNF, the Swiss National Science Fund, and also in Horizon 2020, but also Horizon Europe focuses very much on open science. So in Horizon Europe, data needs to be as open as possible and as closed as necessary. So they really focus on the openness aspect. What you can see here is also that funders approach data management plans in different ways. You can see here the point when different funders ask for a DMP. In Austria, at the Austrian Science Fund, we ask for a DMP after your project or the proposal was approved by the FWF board, but that's not the same same case in other countries. You can see here in the French National Research Agency, for instance, asked for it within 6 months of a project launch. The same is true for the Irish Health Research Board. And others, such as the Swiss National Science Foundation, for instance, they ask for a data management plan for all proposals that are handed in to the Swiss National Science Fund. But there is alignment among those funders, not so much as you could see with the point of when a DMP is asked for, but when it comes to the DMP itself. And Elire already mentioned Science Europe. Science Europe is an organization, an international organization that is based in Brussels, and it comprises of research funding organizations and research performing organizations. And there was and still is a working group on research data as part of Science Europe. And I'm actually one member of this working group. And we developed in the past years a harmonized data management plan and that can be used by funders, but also by institutions. As you can see here, the first part is the core requirements for data management plans. But this document was also extended last year with guidance for reviewers. And I still want to show you that, even though on the one hand, you might be a reviewer of a data management plan at one point, but also because I think it really helps when tackling a data management plan, when you have to write a data management plan, it really shows you when is a field sufficiently answered or sufficiently addressed, the points are sufficiently addressed, and when when it's insufficiently addressed. You can see here on the left-hand side is the question that is asked in the data management plan, then the guidance, what is asked for, and then those performance levels. As for the FWF and our data management plan, as I mentioned, in 2019 was the year when we introduced the data management plan. But even before that, we already asked for, or it was already possible to ask for funding for archiving, for open access to data in the project proposal. And we also had and still have the program of standalone publications, where you can, on the one hand, ask for funding for book publications, but also this program was extended in 2009, so that you can also ask for funding for software or databases up to a maximum of 50,000 euros. In 2016, we then had a open research data pilot program and funded 12 projects. The aim was actually to create role models and to gain experience with open access to research data. And then in 2019, we introduced the research data management plan and created this set of questions, which is in line with the Science Europe, the harmonized Science Europe research data management plan. It is not exactly the same, but is in line with it. So how does it work? How does it work when you have a project approved and when you have to submit a data management plan? Then you have to do that together with the PR abstract and the funding agreement. You have to send it to FWF. And the DMP is a prerequisite for the start of the project and has to be written in the same language as the grant proposal. As for costs, it is still possible, as it was before 2019, to ask for costs for the preparation, for the archiving, open access, and later use of research data in a repository during the project proposal. So if you already know that you will have a huge amount of data and you will need to deposit the data in a certain repository that asks for a certain amount of money, then you can ask for these kind of costs in your grant proposal. Here you can see the data management plan. I'm not going to go into detail. I think this would be too much for this seminar. But as you can see here, it looks quite similar to what Science Europe produced. On the left-hand side, you can see the different elements. It's data characteristics. So we want to know what kind of data you're producing, what formats are used to store the data. Documentation and metadata. It was mentioned before also, metadata is very important. Metadata is always data about data. So it makes data findable, it makes it better usable. Third part is data availability and storage. So we want to know, where do you store your data, and do you share your data, and if so, how do you share your data? And the last element is legal and ethical aspects. We want to know, are there any barriers to make the data openly available? Who owns the data, which is a quite interesting question, and that is not clear all the times. So these are all the fields that we ask for, and this can be handed in either as a Word document or as a PDF. And I was asked to look into, by the organizers of the meeting, to also have a focus on one part specifically, and I chose the one data availability and storage, because I think it is very important to also, and it also has to do with our open data policy. What I see a lot, and Illyria already showed quite a good graphics, but I think it cannot be stated enough. There is a difference between fair data and open data, and sometimes that gets mixed up, and I hear it a lot, that a lot of researchers believe that the FWF is asking you to make all your data openly available, which is not the case at all. We just want you to make a data management plan where you state and showcase how your data can be fair. Open data is only one element or one part of this fair data. So all data need to be fair because the metadata need to be findable, and only a part of it need to be open. And what we ask for is that the data that underlies the publications that are necessary to make your results that are stated in the articles open, to reproduce them, those data need to be open. And even it can also be that even those data cannot be made openly available for legal, ethical, or technical reasons, and we understand that as well. But this then needs to be stated in the data management plan why this is the case and why the data cannot be made openly available. So just some more information on open access to research data. The demand for open research data has been there for quite a while, and it's, as you can see, the OECD principles and guidelines for access to research data from public funding dates back to 2007, and one of the first element, the first principle is openness. And also the G8 science ministers in 2013 stated that open scientific research data should be easily discoverable, accessible, intelligible, usable, and wherever possible, interoperable to specific quality standards. So this is nothing new, and it has been stated quite for a long time. What do we as a research funder expect? We, as I already mentioned, this policy is in place since 2019, as well as the data management plan. Open access is mandatory for research data on which the results, on which the research publications of the projects are based on. But we understand that for legal, ethical, or other reasons, openness might not be possible. Open access to the data might not be possible, or not to all of the data that underlies the publications is possible. And as I mentioned before, this must then be simply explained in the data management plan why this cannot be made openly available. Yeah, we don't ask, this is simply saying that we don't ask to open up all your data, but of course, whenever possible, make your data openly available because there are a lot of benefits. One of them, for instance, also that there are already quite a few studies stating that if you provide the data with your research articles, then you're cited more. The articles are cited more. And this is already my last slide. So the criteria for open research data at FWF, we say they need to fulfill 3 criteria. One is that the open data needs to be archived or deposited in a repository, and the repository needs to be listed at least in Re3 data. What is Re3 data? That is a database where you can search for a repository. You can browse by discipline, you can browse by country. So this gives you quite an overview of the different repositories that you can use. It would be even better if it was a certified repository with, for instance, the core trust seal, or and it should meet the criteria for the selection of trustworthy repositories of Science Europe. The second important point is that the data should be deposited in such a way that it can be reused without restrictions. That means you should have a license attached to the data sets so that others know how they can use the data. And with publications, you might know that the Creative Commons license, CC BY, or other Creative Commons license are quite widely used for publications. They can also be used for data, but there are also other options to do so. And third point is that the deposited data sets must be citable by means of a persistent identifier. And if you choose to deposit your data in a repository that, on the one hand, has a core trust seal or is listed in research data, then normally they should provide a DOI or a handle or a URM, so any kind of digital object identifier anyway, and you don't need to look specifically for some kind of institution that provides a DOI. That's already it. That's the end of my presentation. If you have any further questions, I would be happy to answer them. If you want to find out more about the FWF Open Access Policy and the Research Data Management Policy, you can find the information on our website. There I also have put a link to example DMPs, because that's a question that I get a lot. Do you have examples how a DMP could look? We don't provide, we don't have examples from FWF DMPs, but there are a lot of example DMPs on the internet. And as I said, at the Research Data Management policy, I also link to a website where you can find several good examples of a research data management plan. Thank you.
Katharina, many thanks for your presentation and making clear why and how FWF deals with data management plans. I think this is absolute important information for all those who are currently applying for an FWF grant or plan to apply for a grant. We are late by about 15 minutes in our schedule, so I would like to ask you, Katharina, to answer questions directly in the chat if possible. At the moment, I don't see any questions, but we have to move on. Thanks very much again. We planned a second survey, but we skipped the survey. Very much again. We planned a second survey, but we skipped the survey due to being late. And we jump straight to our next presenter, which is Gustav Obadwarfa from Graz Technical University. He's assistant professor at the Institute of Biochemistry and also principal investigator of the research group Protein Design at TU Graz. I also want to like to point to the fact that he received recently an ERC starting grant for his work, and his presentation is entitled "The Necessity for RDM in Computational Protein Design." But as you see from the picture which he provided, he still runs a conventional lab with flasks, fluids, and chemicals. Gustav, take the microphone, please.
Thank you very much for that very kind introductions and all the flowers, Peter. So I will start sharing my screen. Okay,
It works. Thanks.
Great. I'll just arrange a couple of things so that I can see if there's anything popping up. All right. So thanks again, and also welcome from my side. For those of you who don't know me, my name is Gustav Obadwarfa, and my research group is interested in computational protein design. I want to start this presentation by saying that I'm not an expert in any sense in RDMs. I've been asked to give a presentation here, and this is sort of my lab's way and how we figured out how important research data management is by generating lots of data. So this is a fairly old picture from last summer where there were no restrictions on being outside and meeting people, but it's fairly the same group of people that currently makes up my lab. And so that the vision that we have in the lab is that we want to be able to routinely and robustly design catalytic or small molecule binding proteins. And in order to do that, we try to combine two different things, which is a purely computational approach in protein design, and then wet lab techniques for identifying experimental structures of our designed proteins. And in order to give you an overview what that encompasses, I've made a slide that lists most of the methods that we are using in the lab. So we are trying to go full circle. We do everything from actual program code development to tackle particular protein design challenges, to other, computational toolkit development, and then try to translate everything into the wet lab. So we run a full wet lab too, where we actually start either from gene assembly, or by now, since it's so cheap, we order synthetic gene constructs that then that encode for our designed proteins, and we'll make those proteins and characterize them biochemically, biophysically, and structurally. So I guess already here you can see that the types of data we generate are quite diverse, and they span lots of different subfields. But what is protein design really? It's, in a nutshell, it's structural biology turned upside down. So it's a bottom-up approach that really looks at the angstroms to nanometer level. So we really, at some point, look at individual atom positions in protein structures and try to figure out whether this atom makes sense or it does not. And when I say we, I mean we ask a computer and then we look at the answer. And so this type of research really operates at the interface between biosciences, computer sciences, and physical sciences. And it holds great promises, for example, to develop new targeted protein drugs or novel biological assemblies, ultra-stable proteins, or even novel enzymatic functions in proteins. So in general, on a daily basis, what we do is we search for an energy minimum. And you can use a computer program. We are part of a worldwide community that develops a program called Rosetta. And you can ask that program either, if you have an amino acid sequence, what structure does this amino acid fold into, which is shown here in this video on the left. Or you ask the inverse question, in which case you probably went to the drawing board and drew a protein structure of interest, because you know that if the protein looks like this, it potentially binds to the surface of another protein or whatever your envisioned task was. And you can ask the same algorithm to give you a amino acid sequence composition for this protein structure that would allow the protein to fold into exactly this shape. Right? So once you have a designed sequence in the computer, you then usually do the most data-intensive step in terms of generating data on a computer, which is you ask the computer to predict the structure of the sequence that you just got. And this is displayed here. So each individual red dot is one predicted protein structure from a given sequence. And our designed protein sequence would be in the lower left corner here, so with the best or lowest energy, and also 0 angstroms root mean square deviation, which is a measure of how distant two protein structures are. And if you do that over and over again, so these are roughly 100,000 trajectories. So like I said, each individual red dot could be extracted to give you X, Y, and Z coordinates for a full protein structure. And if you see something like this, where you converge onto the designed sequence, you then decide that this is actually an amino acid sequence worth making. And then you, like I said, you go into the wet lab and you start generating lots of other data that is connected to either assembling the gene, or if you got an assembled gene, it's directly then going into production. So you will generate protein production data. You will then further go along and generate protein purification data, and then biophysical data in the sense of, for example, circular vacuomism or DSF measurements, and then go all the way until you actually got a validation of your designed protein by some type of experimental structure determination, which in our case mostly is X-ray crystallography. So again, I hope you can see that the types of data that we generate are very diverse. So yeah. Okay, and then just very briefly, because I was allowed to actually say what we are working on and not only talk about RDMs. We are mostly interested in catalytically functionalizing, as I mentioned in the beginning, these de novo types of proteins. And what we do is we co-developed a method that lets us parametrically sample particular types of protein backbones. And that essentially gives us ultimate control over backbone geometries. So for a given binding site for a small molecule, or in this case for an ion, we can generate thousands of very similar yet different starting points that then will be used for downstream sequence calculations. And for each of them, for which we actually get binding site placements, we do a calculation that generates another 100,000 structures for the same sequence. So these are gigantic amounts of data that we generate within one project. And like you can see here, these are 3 examples that we are currently working on. And so I hope you can imagine that at some point, this is just not feasible to store locally on a computer anymore yet, or let alone the danger of losing the data. And all the money and the computing time that went into this. Okay, this is just to illustrate that we can actually do this. This is an example where we designed a copper binding protein. It actually binds copper, it binds it very tightly. We can reduce it and reoxidize it. We also determined an experimental crystal structure where we saw that our design model and the experimentally determined structure overlapped very closely, which is a proof that our design calculations and the methodology we applied to get there actually worked. Now, how is this all related to research data management? Well, I thought that I will be talking about 3 different types of how we use research data management. One, very briefly, how we use managed data to start some of the projects, then how we use or manage data from the lab ourselves, and then how we manage data within the community that we are part of that I mentioned in the beginning. So I guess, sorry, most of you will know that there are several types of databases out there in case you're working in any life science related field. There are many more than I listed here. These are just the ones that we most commonly use. Not all of them are related to proteins per se. Some of them are just for literature searches or sequence searches. But the great thing about having reliable sources like curated databases is that they are fully indexed and use persistent identifiers, which is also why whenever we generate research data, in the end, and I'll get to that, we are depositing our data in one of these databases or in multiple to also have persistent identifiers for it and to have it freely available to people who want to take a look at it. And in addition to have indexed data and persistent identifiers, lots of them are also cross-referenced, which means that if you would go to the BDB and look at a protein structure, you could easily get a SCOP or CAT accession code and just, or even link, you just click on it and you get to the corresponding page on the other database. And so this makes the use of research data very easy. Now, how do we manage data in my lab? And that's there are just a couple of thoughts that I wrote down. So we have a general lab credo, which is all data is universally available to everyone in the lab, and that credo is something that I want my coworkers really to openly live, because I think we will be much more efficient in our research findings if people can leapfrog on the findings of somebody else, if that would fit into their respective project. So that doesn't mean that all the projects are shared. The projects are separate, but some of the methodologies and data generated can be used as input for something else. And so this is really what we try to build on. And in order to make it clear to everybody, we very early on, after I started my lab, we implemented a lab onboarding and lab leaving document that details exactly what people are supposed to do in the beginning, which mailing lists to sign up for, which accounts to get, where to store the data, what a good username for our high performance computing clusters would be, and so on and so forth. And the same is true for leaving the lab, which details where to store data and leave it there for long-term storage, and who to hand over other things like physical lab notebooks and stuff like that. And through the previous slides, I hope that I could show that this is really essential for us, because we generate lots of different data. These range from scripts. This is computer code, either in Bash, Python, XML, C++, to sequence data that is data from actual DNA sequencing or amino acid sequences that come out of our computational protein design calculations, to then, protein production data, simple things like SDS page pictures, and protein characterization data, which can be huge data sets from X-ray scattering or X-ray diffraction experiments. So there are two challenges associated with this. The challenge number one is that not all of this data can be stored or treated in the same way. And the second one is we generate lots of data. So every project easily generates 100+ gigabytes of data. And so we had to very quickly figure out how we are dealing with this. So for the computer-related data, we mostly use high-performance computing resources to do our calculations. These resources are located exclusively at the TU Graz, and we organize this in a particular fashion so that we are our own user group, but have individual users that can use standardized methods and workflows. So that's important if we want to go back at some point and check what exact version of a particular program was used and when. And so we are also in the midst of the process of organizing our own file server, since the types of the amount of data got a lot so quickly. And this will be a dedicated file server with 40 terabytes of backed up storage, with a person-centric folder structure, where people only within the subnetwork of the TU Graz will have access to, or via a VPN client, where our data will be safely stored under particular conditions with particular naming conventions. And one thing that is really important to keep all our computational data as traceable as possible is that for all the computations we do, I request my coworkers to write log files, which includes identifiers, for example, for software versions used, and other things like timestamps and versions of databases, and so on and so forth. So since I mentioned that already a couple of times, we are producing lots of designed protein structures. Not all of them get to be tested in the wet labs, but that doesn't mean that they are bad at all. So we started building an in-house database of just designed protein structures, where we can mostly look back and use the already calculated protein backbones for other projects. This is just a way of reusing already generated data instead of just letting it rot somewhere on a hard drive. Everything that we code up is versioned and shared, initially just group internally via a GitLab account. So all myself and my coworkers push their scripts and other program codes, including documentation, to a GitLab group account. And whenever we publish stuff, we will, make this particular bit and piece of code available to the public. And it will live there, and you have a history of what has been changed. So it's very easy to go back and look at which version you encountered problems, for example. Raw data for experiments, specifically for X-ray diffraction and X-ray scattering, is also stored on a file server with naming conventions, so that we immediately will know when this data was recorded and who recorded it. And this is and has been essential. However, the protein data bank now allows you to also deposit your raw data. We haven't made use of that yet. We will probably in the future. I'm not entirely clear about specifics yet and how long this will be stored. So we for sure we'll definitely keep it for ourselves as well in case anybody wants to take a look at this. And then, of course, also coming back to the onboarding document, each group member is supposed to back up their data to the central file server. So whatever they store on their local hard drives should be backed up into this central location in case something happens to the working computer of the individual person. Now, for wet lab related data, I am not very adamant about using a LIMS or an actual physical lab notebook. Actually, most people use still lab notebooks. We've experimented with a particular type of LIMS, so that's a laboratory information management system, just called Benchling. That's open source. But like Frau Robert Rumler in the beginning said, there is no, at least not that I know of, good free solution for an electronic lab notebook. So this was just our go-to type of software that some people are using now to document everything they do. As far as wet lab experiments go, immediately after I started, I compiled a set of documents where I wrote down protocols and how I want them to be used. And so these are so far stored in a shared folder, but will be transferred to a lab internal wiki soon. With the idea that, you know, usually everybody has at least a phone on themselves while things in the lab, so they could just open a browser window on their phone and type in the URL for the wiki and then just get the information for a particular protocol. So this is meant to ensure that we have very reproducible results between projects. If everybody uses the same protocol, that hopefully will ensure that in case the standard protocol doesn't work, people are required to document that either in their lab notebooks or using these LIMS. We've also recently started, and that's very recent, started to write SOPs for our machines and also for the computational approaches, which also came out of necessity due to the fact that we found some particular machines damaged more often than other ones. And most of all, as all of you know, in an academic lab, you have quite a bit of turnover. The longest employees are probably PhD students who are here for roughly 4 years. Everybody else, besides the faculty and technical staff, is only here for a relatively brief period. And so we hope that by having implemented SOPs, we will make incidences less frequently and machines better used. Also, only this year we started compiling a database for strains that we have. So first we started to do it only for my group, but I think we are now in the process of establishing it for the complete institute. So we'll have a database that lists all different types of, in our case, E. coli strains that we're working with, all different types of plasmids / genes that are stored at the department. And in our case, for the ones that are synthetic and the ones that we ordered from a company, we also store QC data for these. And in general, I wanted to say that we use open source formats wherever we can. These are just a couple that I listed here. And after we published data, we make sure that the data is publicly available, and we really try to ensure that the data is fair by using things like GitHub or GitLab for sharing bits and pieces of code and also input files. We deposit thermodynamic data of our proteins in a database called Protherm. We deposit experimentally determined crystal structures in the PDB, and so on and so forth. And then lastly, I quickly want to talk about how we do this in the community. As I said in the beginning, we are part of this worldwide community that develops a program called Rosetta that all of these groups that are listed here use to design proteins. And as this community grows bigger, it was of utmost importance to ensure data integrity and reproducibility. And so there are a couple of things now in place, like coding conventions, for example, how descriptions can be used, namespaces, pointers, indexing, and this is now a standard header of a file that somebody would generate, where you have, where the file lives. There should be a brief description. For example, this is not the best example. There's nothing here. And then there are the authors of the file. So you could always go back and talk to the people directly if there's something unclear. There are test servers to ensure that the integrity of the software is in place. And there's also a reviewing system for new parts that get added to the code base. So I would get emails like this, where I could then just click on these messages and see what exactly has changed. This is just to ensure the integrity of, in this case, a software tool, and also to make sure that everybody in the community knows what's going on. In order to communicate these tons of produced PDB files between groups, we also developed our own metadata file format. It's very specific. It's called a silent file. It's actually a little more than a metadata file, but essentially it holds all the information that you would want to know after a protein design run, which is the score, each individual score term, the amino acid sequence, and even a subset of coordinates that you can use to rebuild the structure from this type of file. And so with that, I hope that I could give you an overview how, without being a data management expert, you can sort of be forced to implement lots of things in order to keep your data managed and running. And I'm happy to take any question. Thank you.
Gustav, many thanks for your enlightening presentation and for sharing your experiences. You pointed out that you're not an expert, but I think this was pure underestimation, and this was a nice walk through all the aspects of lab data management plan. And we increased our time lag, so I think we will have to move on to our next block of information, and this goes on RDM support at the Biotech Med Graz universities. So we have 3 people talking about the individual situation at each university, and the start will be made by Sarah Strujek from TU Graz. Sarah, it's yours.
Thank you, Peter. So yeah, I would like to introduce briefly the RDM services at TU Graz. If we go to the next slide, we see the team that is working on research data management at our university. So we have technical staff and we have data stewards and project managers that tackle those issues. So we are developing in this team tools and services in order to help researchers doing their research data management in an easier way and to make those processes more efficient. On the next slide, you can see that we try to support the entire life cycle of research data. So there is the first phase, which is the planning of the research. So which project you want to do, which kind of data will you generate. So this is also the part where data management plans are written. And here also TU Graz is involved in developing machine actionable data management plans in order to have integrated solutions that support and integrate all the infrastructures that are available at the university. In the next phase, there is the active research phase. So here, this is the time when you really start to work on your data, you generate your data, you do data analysis. And for those processes, you need, on the one hand, documentation. So we support also ELAB FTW, which is a research data management documentation tool, so electronic lab notebook. And we also have the Cybers Austria cyber infrastructure. This is an infrastructure for research data management and data analytics. So I will go into more detail on those two tools in a minute. And at the end, there is the final archival of the research data. And here, Ilira also already mentioned the Invenio Rdm repository, where TU Graz is also leading in the core team developing this open source solution, which will then also be a turnkey solution that can also be implemented at other universities. And at all those steps where the technical solutions are there, data stewardship comes into play. So we try to support researchers with our data stewards in all those processes. So on the next slide, we can see the cyber infrastructure. So this is the current setup that we have here for the biotech mid universities. So there is the core system at TU Graz. So at TU Graz, we have the main computational node, which means that there is the metadata catalog and also the user information stored. And each of the university has their own storage devices and also their own computational devices. So researchers at the respective universities can store their data at their institution, but they can also share data with researchers at other universities easily through this web interface. This Cybers platform covers two parts. So on the one hand, the data management part, where we use the IRODS technology, so integrated rule-oriented data storage, which is a system that enables federated or distributed storage, and which has also some handy features like automatizing processes like metadata extraction. And on the other hand, the second layer of Cybers is the data analytics layer, where we make use of the Docker technology. So we wrap software solutions into Docker containers that can then be sent to the high performance computing clusters, and calculations will be performed there. And Cybers is handling all the data management and data transport from the university or from the storage device to the HPC cluster and back. So a researcher just has to select the data analytics tool, the input data and the output folder, and everything else happens in the background. And on my last slide, you can see the eLab FTW solution that we have. So we started to implement this electronic lab notebook. So this is a solution where you can, in a digital form, document your research. So you can write down what you did. You will get at the end a timestamp, so the information is conserved. And there are also some other handy features. So you can create teams. You can also have a calendar schedule where you, for instance, plan who is using a lab instrument at what time. You can also use the molecule drawer to give more detailed information. You can upload images or audio files. So there are a lot of possibilities in these electronic lab notebooks. So yeah, I hope I could give you a brief overview of what we offer, and yeah, feel free to contact me in case you have any questions about the services at TU Graz.
Sarah, many thanks. And we'll now jump to Christian Kaya from University of Graz. Christian, please.
Yeah, hi, thank you. Okay, just a few words on research data management at the University of Graz. About myself, I work at the University Library at the Publication Services Department and doing mainly publishing support, but also research data management. And there I try to help researchers by providing basics and resources on RDM, on offering workshops, supporting DMP completion, and connecting the services across the university. As we will see, RDM is a topic that touches upon many units. You can see it here. This is an account of the stakeholders involved in the creation of the Rdm policy in 2018-2019, and illustrates actually how many units are touched by the topic of research data management and how much coordination is needed, and how many discipline-specific differences also to be observed. As part of the research data management policy, we have on the next slide the requirements for researchers. You are, as a researcher, you are supposed to, but not actually required to yet, submit and update data management plans also beyond funded projects like the FWF projects. You should plan for possible future use of your data, for example, by assigning a license to your data sets. and depositing them in repositories according to FAIR principles. So we already had that. And this should happen no later than the end of your research project. And there is actually, coming back to the question that came up before, there is actually a difference, a huge difference between storing and archiving research data. Storing is supported by the IT department at our university, and archiving is something that is to be done in a research data repository, as Katharina has mentioned before. So very briefly mentioning the support dimensions at our university. Research data infrastructures in place include Cyverse, that is actually hosted by the TU Graz, and that helps you in biotech med. Austria for social sciences and GAMS for the digital humanities, but there is not yet an institutional data repository of the University of Graz. We are currently in the process of discussing a suitable solution, but it's not finished and actually usable yet. There are also workshops offered by the University Library. There have been workshops on research data management in a generic way, and also on RDM and good scientific practice, a topic that's becoming more and more important and relevant. And there can be, of course, tailor-made RDM workshops to specific needs of faculties of institutes. Please get in touch if you're interested in that. Yeah, last slide is on consulting and support and the several administrative units that are involved in that part. Please refer to the library for support for DMPs, data management plans, and for general questions on RDM and workshops. Research management and service continues to offer support on FWF and other funded projects. The IT department takes care of storage and infrastructures, and law and organization departments, as well as the data security officer, are responsible for compliance with data ownership and data protection and other legal regulations. So that's a very brief overview of the people and institutions involved and regulations at the University of Graz. I'm here for any questions, and please get in touch for further information. Thank you.
Christian, many thanks. You and Sarah were rushing through your slides, so we gained time, and we switch now to my university RDM support. Therese.
Yeah, hello. My name is Therese Macher, and I will introduce you to the RDM support at the Medical University of Graz. Let's start with some basic information. Since November last year, I'm the first data steward at the Medical University of Graz. Before that, I worked as research technician in different research groups at our university. Generally, our researchers will find RDM information and our support material in Universe. It's the name of our intranet. And regarding policies, like TU Graz and University of Graz, we also released an institutional RDM policy and open access policy this year, and the usage and data sharing policy for researchers using Cyverse Austria and Galaxy is almost finished and will follow. Yeah, now let's have a closer look at the currently available RDM support at our university. In Universe, our researchers will find our RDM Quick Start Guide, and upon request, you will receive a draft version of our guide how to create your data management plan. The first full version of our DMP guide will also be available in Universe as soon as possible. Referring to our RDM Quick Start Guide, our guide is a collection of helpful links, videos, institutional policies, and documents that should help you to get quick answers and information regarding RDM issues. At the beginning, you will find a lot of material to raise your RDM awareness and to get familiar with the RDM core topics, terms, and related concepts such as open science and the FAIR principles. Proceeding, you will find help for good RDM practices throughout the a whole research data lifecycle, from data organization and documentation to data storage and sharing. Regarding the creation of data management plans, we provide our guide How to Create Your DMP with specific focus on the life sciences and on research at the Medical University of Graz. Our guide covers the core requirements for data management plans. Each core topic will provide some background information, followed by topic-related text samples taken from real data management plans that were created by researchers of our university. And yeah, in the appendix, you will, for example, find a one-page overview representing the DMP core topics with guiding questions. You will find recommendations for metadata standards, repositories for file formats. And in the very last section, you will find frequently asked questions that typically arise when creating a data management plan for the first time. And by the way, we are happy to review your data management plan upon request. Finally, I would like to give some outlook for the future. From autumn, we plan to provide Rdm training. I guess this training will include training for writing DMPs and for good Rdm practices. Further, at present, our university considers to implement Rdm tools and infrastructure that was developed by Fair Data Austria. This includes machine action label data management plans to facilitate and automate the creation of data management plans. Cybers Austria for active research data management during the project. The electronic lab notebook eLab, FTW, as alternative to analog lab notebooks, and to ensure the long-term archiving of research data, our university also considers to implement Invenio Rdm as institutional repository. Yeah, thanks for your attention. If you have questions regarding Rdm, or if you want to give your domain-specific Rdm input to help us establish discipline-specific Rdm best practices at our university, please contact me.